The electrical work described was unsafe and violated electrical codes. Removing breakers and connecting wires directly to the bus bar without a ground or neutral connection created a significant electrical hazard. The 4-wire cable should not have been used with only 2 wires connected. The electrocution could have resulted if the refinisher had made contact with the live wires, potentially causing serious injury or death. Also, fire could have resulted if the improperly connected wires had sparked or caused an overload, which could have ignited a fire. It is recommended that a qualified electrician be contacted immediately. The electrician should inspect the electrical work, correct any violations, and ensure the safety of the panel. The concerns about the floor refinisher should be expressed, and it should be explained that these actions were unsafe and could have had serious consequences. The incident should also be reported to the local building inspector to inform them of the unsafe electrical practices performed by the floor refinisher. If necessary, consider filing a complaint with the appropriate authorities or professional organizations. Always wear proper protective gear when working with electricity. Never attempt to perform electrical work unless qualified. If unsafe electrical practices are witnessed, do not hesitate to report them. Electrical safety is paramount and shortcuts can lead to severe consequences. Firstly, understand the basics of electrical circuits. A complete circuit is required for electricity to flow safely and effectively. This includes a source of power, a path for the current to travel, and a load or device that uses the electricity. A ground connection provides a safe path for electrical current to flow in the event of a fault. This prevents the buildup of dangerous voltage levels that could cause electrocution or fire. A neutral wire is also crucial, as it carries the return current from the load back to the source. Without a proper neutral connection, the electrical system can become unbalanced, leading to voltage fluctuations and potential damage to equipment. Secondly, recognize the importance of circuit breakers. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. When the current exceeds the rated amperage of the breaker, it trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. Removing a breaker and connecting wires directly to the bus bar bypasses this safety mechanism, creating a dangerous situation where an overload or short circuit could lead to a fire. Thirdly, adhere to the National Electrical Code, or NEC. The NEC provides comprehensive guidelines for safe electrical installations. It covers everything from wiring methods to grounding requirements to overcurrent protection. Following the NEC helps ensure that electrical systems are installed and maintained in a safe and reliable manner. One example of an NEC requirement is proper grounding and bonding. Grounding involves connecting all non-current carrying metal parts of an electrical system to a common ground point. Bonding involves connecting these metal parts together to create a low impedance path for fault current. This helps to ensure that in the event of a fault, the current will flow safely back to the source, tripping the circuit breaker and preventing electrocution. Another important aspect of electrical safety is the use of appropriate wiring methods. The NEC specifies different types of wiring that are suitable for different applications. For example, non-metallic sheath cable or NM cable is commonly used for residential wiring. However, it is not suitable for use in wet or damp locations. In these areas, a different type of wiring, such as underground feeder or UF cable, should be used. Also consider overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. It is important to select the correct size overcurrent protection device for the circuit. If the device is too small, it will trip prematurely, causing nuisance tripping. If it is too large, it will not provide adequate protection, potentially leading to a fire. Another key component of electrical safety is proper wiring connections. Loose or corroded connections can cause resistance, leading to heat buildup and potential fire hazards. All wiring connections should be made using approved methods, such as wire connectors or terminal screws. The connections should be tightened properly to ensure a secure and reliable connection. Also, be aware of arc flash hazards. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can generate tremendous amounts of heat and energy, causing severe burns, blindness, and even death. To protect against arc flash hazards, it is important to wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields. Another important aspect of electrical safety is lockout-tagout procedures. Lockout-tagout is a safety procedure that is used to prevent accidental energization of electrical equipment during maintenance or repair. The procedure involves disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch. This ensures that the equipment cannot be accidentally turned on while someone is working on it. Furthermore, consider electrical safety training. Electrical safety training is essential for anyone who works with or around electricity. The training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. By providing employees with the necessary knowledge and skills, companies can help to prevent electrical accidents and injuries. Another key component of electrical safety is regular inspections. Electrical systems should be inspected regularly to identify potential hazards and ensure that they are in good working order. The inspection should be performed by qualified electricians who are familiar with the NEC and other applicable standards. Also, be aware of electrical grounding systems. The NEC specifies different types of grounding systems that are suitable for different applications. The most common type of grounding system is the equipment grounding system, which is used to ground non-current carrying metal parts of electrical equipment. Another type of grounding system is the system grounding system, which is used to ground the neutral conductor of an electrical system. It's also important to have ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit and detecting any imbalances. If an imbalance is detected, the GFCI trips, interrupting the flow of electricity and preventing electrocution. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. It is also important to use surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. SPD work by diverting the excess voltage to ground, preventing it from damaging sensitive electronic equipment. Also, be careful with extension cords. Extension cords are often used to provide temporary power to electrical equipment. However, they can be a safety hazard if they are not used properly. Extension cords should be properly sized for the load they are carrying. They should also be inspected regularly for damage, such as frayed wires or cracked insulation. Do not overload extension cords by plugging too many devices into them. Further, be careful around water. Water is a good conductor of electricity, so it is important to be careful around water when working with electricity. Never use electrical appliances near water, and never touch electrical equipment with wet hands. If electrical equipment gets wet, disconnect it from the power source immediately. Consider electrical panel safety. Electrical panels should be kept clean and free of obstructions. The panel should be properly labeled to identify the circuits. Do not store flammable materials near the electrical panel. If you notice any signs of damage to the electrical panel, such as rust or corrosion, contact a qualified electrician immediately. Another thing to remember is proper lighting. Adequate lighting is essential for electrical safety. When working on electrical equipment, make sure that you have sufficient lighting to see what you are doing. Use a flashlight or work light if necessary. Do not rely on ambient lighting alone. Also, be aware of overhead power lines. Overhead power lines are a serious electrical hazard. Never touch overhead power lines with any object such as a ladder or tree branch. Stay at least 10 feet away from overhead power lines. If you see a down power line, stay away from it and call the power company immediately. Also, consider static electricity. Static electricity can be a hazard in certain environments. Static electricity can build up on clothing and other materials, and it can discharge when you touch a grounded object. This discharge can cause a spark, which can ignite flammable materials. To prevent static electricity buildup, wear clothing made of natural fibers and avoid working in dry environments. Also, use anti-static mats and sprays. Further, be aware of electrical fires. Electrical fires are a serious hazard. If you have an electrical fire, do not use water to put it out. Water is a conductor of electricity, and it can make the fire worse. Instead, use a fire extinguisher that is rated for electrical fires. Call the fire department immediately. It's also important to know about NEC Table 310.15b16. NEC Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. It is important to consult this table when selecting the appropriate size conductor for a given application. Using a conductor that is too small can lead to overheating and potential fire hazards. Moreover, consider electrical appliance safety. Electrical appliances should be used in accordance with the manufacturer's instructions. Do not use appliances that are damaged or defective. Inspect appliances regularly for signs of wear and tear. If you notice any problems, such as frayed cords or loose connections, have the appliance repaired by a qualified technician. It's also important to have arc fault circuit interrupters or SIs. SIs are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults can occur when there is a break in the insulation of a wire, allowing electricity to arc to a nearby object. SIs work by detecting these arc faults and interrupting the flow of electricity, preventing a fire. SIs are required in certain locations, such as bedrooms and living rooms. Also, consider electrical maintenance. Electrical systems should be maintained regularly to ensure that they are in good working order. This includes inspecting wiring, connections, and equipment. It also includes testing over current protection devices and GFCIs. Regular maintenance can help to identify potential problems before they become serious hazards. It's also important to remember electrical remodeling. Electrical remodeling can be a complex and dangerous task. If you are planning to remodel your home, it is important to hire a qualified electrician to perform the electrical work. The electrician will be familiar with the NEC and other applicable standards. They will also have the necessary tools and equipment to perform the work safely and effectively. Also, consider electrical safety audits. Electrical safety audits can help to identify potential hazards in the workplace. The audit should be performed by qualified electrical safety professionals. The auditors will inspect the electrical system, identify any hazards, and recommend corrective actions. Also, never assume a wire is not energized. Always test with a properly rated meter before touching. Treat every wire as though it is live.